So let's see the steps there. So you do this derivative, what's going to happen? You got to use what here?
Product rule.
Product rule. I love it. So this first guy will be just like this. That's pretty easy, right?
Mm-hmm.
Second guy stays the same. So this 4 just comes down. Not a big deal. Plus, what happens here? Yeah, the 5 comes down. And then the chain will have another 2 come there. Right? Again, if you need to, you can show yourself every step. I'm just hoping right here I can maybe... That's going to be a 10. So that 5 came down.
Why is it x minus 3?
What's up?
Just kidding.
Okay.
Yeah.
So the 5 came down, times this to the 4th, times the derivative of the inside. The derivative of the inside is 2, so it's just going to be a 10. Kabam. How are we doing so far? Good? Mm-hmm. Alright. And then now it's just remembering how to factor this stuff. So I can take a 2 out, right? How many x minus 3's?
3 of them.
3 of them? How many 2x plus 3's?
4.
4 of them? Notice that real quick. The powers, what do they add up to be in both? 8. I like that. Start off with a 9th power. They're each going to be 8 degrees. Kind of makes sense in a way. And what's left here in the beginning is going to be a 2. And one of these 2x plus 3's, right? Because I had one more. So I have 2x plus 3's. Plus 5. And then one of these is going to be left here. Because I have 4 of them. I only took 3 of them out. Like that. Now this step should be bread and butter. This step should be, yes, Jeff, this I could do this all day. Now, of course, it's not quite done. So over here, what do you get inside there? I get 4x plus 5x, 9x, plus 6 minus 15, so minus 9. So I can take a 9 out, that's where the 18 comes from. And then there's an x minus 1 left in there. Thank you, guys. So this is what I mean. Every now and again I'll tell somebody, the most evil problems in the book are the ones that are like this. They say, verify that this. And they give you the answer. And you give up halfway. You're like, that doesn't look anything like... No, it doesn't. It's not going to look anything like it's supposed to until the end. So you're like, where's that 18? I don't see 18. I must have done this all wrong. Let me start again. No, you're wasting time. Keep going. The 18 is going to come because the 9 is coming out. You don't see that till you're there. So don't give up on something just because it doesn't look like it's supposed to. It's not supposed to look like it's supposed to until you're done. Right? Okay. Some of you guys who do art, you might feel the same way sometimes. Oh, look at that. Look at that. I meant to make a rock there. Alright. Bob Ross. It's a rock now. Rest in peace. Let's see. Critical numbers for the first derivative. So now that we know this is true, what are my critical numbers going to be? Is this ever undefined? No. Well, where's it 0? It's 0 where?
3.
3.
Negative 3.
Negative 3 halves. And 1. I like it. So this is where f prime equals 0, f prime of x always exists. So there's no critical numbers from that. Okay, cool. So forever differentiable thing. So now that we know the critical numbers, we just have to test them. So this is called the first derivative test, because math people are creative. We use first derivative to make that. That might give you a clue, though. I don't know if anybody else was thinking this. As I drew this, it would mean what's true at this point. Then the second derivative at this point would be, remember what we said earlier. The second derivative, it's that way. So that's cupped down. So the second derivative would be negative. So another way to do this is a second derivative test. You take a second derivative. No, I don't want to. So screw that. Right? So it depends. It's nice to have two options. I don't know if you guys understand. We'll do another problem here that's a little easier. It's got a better derivative. But if I took the second derivative, I could just plug the points in. If it's cup up, it's a what? If it's cup up, at this point, it's got to be a minimum. If it's cup down, it's got to be a... It's awesome. It's a beautiful test. If the derivative is nice, I would say the derivative would not be nice. It's a 3-part product rule. I don't feel like doing that. So let's just do the first derivative test. All right, first derivative, I got there staring at me. You guys kind of with me a little bit? All right, so how do I do part C? What do I do? Do the line.
The other line.
So put on there negative 3/2. And I'm going to bring back something. We'll see how many people remember this. Do you remember anything about multiplicities? You don't have to, by the way. But it's an awesome shortcut. Who remembers something about what multiplicities tell you? Besides being an awesome Michael Keaton.
Where
Yeah.
it crosses the x-axis twice. And one with...
So for example, the multiplicity of the root 3 is 3.
Positive or negative.
It tells you what the function does at that root. So what does a cube do through the 0? It goes through, doesn't it? What would a square do? It would turn around. So odd multiplicities go through. They change sign. If it was negative on this side, it's going to be positive on that side. Even multiplicities stay the same sign. So what the hell do I mean by that? I don't freaking know. 0. I always try to plug 0 in first. So what do you get when you plug a 0 in? What sign? I don't care about the number. I just care about what the sign is. I want to know, is the slope positive or is the slope negative? So when you plug a 0 in, of course to the first derivative, right? I want to know what the slope is. Yeah, you get positive, negative, positive, negative. I like it. So it's positive here. So everybody cool with that? You guys with me there? And if you get the number, I don't care. All you really need for this picture is the positive or negative. Now watch this. 1 has multiplicity 1, which means it's going to go through. So it was positive here, therefore it must be negative there. Bless you. 3 has multiplicity 3. It's got an odd multiplicity. It's going to change signs through it. And negative 3/2, it came from something with a even multiplicity, so it's going to say the same sign on either side of it. Now, how else could you get that? You could plug negative 5 in, you could plug in 2, you could plug in 8, and get the same things I just did. So you don't have to do the shortcut, but the shortcut kicks so much ass. Some shortcuts are stupid. This is not a stupid shortcut. This is a good one to know. But if you don't use it, I don't care. It's fine. I'm not going to take it personal. Screw you and your shortcut. So what can I say here at the end? What's happening? In fact, can you try to draw, even better than, you can always draw the line. So it would be like going up and it would be flat and then it would be going up again. But can you do like it's going up and then it's flat. It's going up, then it's flat, going down, flat, up. So it looks like there's a maximum here and a minimum there. And I've even got like a very rough image of what the function looks like. The reason it's rough is I don't know how deep this valley is. I don't know how high that mountain is. Right? Sorry. It just happens. I won't do that to you. Is everybody good with me so far here? You guys with me? Everybody kind of with me? A little bit? Alright. If you don't want to do what I just did, you can say, okay, it's up, flat, down, flat, up. To me, it's just easier to see. It's not as easy to see here that it's a max and here it's a min. It's just easier if you actually draw the curve. But either way. I can't remember what the book does. So what's the max? Max occurs at what x value?
1.
1. So what's the point? 1 what? Comes out to be something huge. You got to be careful now. Where are you plugging 1?
In the original function.
The original function. I want to know where the function is at 1. I already know that the slope is 0, so if I plug it in there, of course I'm going to get 0. I want to know where the function is at 1. So it's
50,000?
something big. Yeah, it's like 5 to the 5th power times negative 2 to the 4th power. So it's 16 times something. I don't even know. So yeah, 50,000 something sounds about right. You guys, everybody with what's happening? We're just plugging a 1 into here. I want to know what f of 1 is to figure out its y piece. And it comes out to be what exactly?
50,000.
50,000? Neat. All right.
Exactly.
That's neat. I wish I could take credit for that, but I can't. I didn't make it happen. So the maximum occurs at 1/50,000. And the min occurs where? At 3, good.
3 and 0.
0, yeah, think of it. Sometimes that'll happen, that's nice. Because when you plug a 3 into the original, it's 0. And why does that sort of happen? There's always going to be repeats when you do this kind of function. We've done enough of these for you to realize. X minus 3 is what came out. It came out. So it's going to be repeated factors for this. But there's something, I'm going to get this other piece that just came out of nowhere. Alright, maybe. How do we feel about that so far? This is section 4.1, local max and mins. This whole idea, we're going to expand on what you did in pre-calculus. Not only are you going to find like n behavior, multiplicity at the roots, behavior at the roots. We're also going to talk about, well, is it cup down or is it cup up? Stuff like that. So we can really draw a more detailed sketch by hand. That's kind of like what we're headed towards. What about number 2 here? You guys were able to do part A? This wasn't a too bad one, right? It was pretty quick. Because the derivative of x is 1, and then the derivative of e to the negative 2x squared is itself, the derivative of negative 2x squared is
Negative 4x.
negative 4x, so that'll come down, multiplied by the x that's there already. So that's just the product rule, right? That's derivative of x, and this is derivative of e to the negative 2x squared times the x that's there. And then, of course, what can come out is this little dude here. And you're left with 1 minus 4x squared. Now, is this factored all the way? No, right? So I was a little evil on that one, but I don't care. You know that already. How do you factor this further?
1 minus 2x and 1 plus 2.
Yeah, that's your thank God problem, right? That's your difference of squares. I don't care what it looks like, you say thank God or thank whatever deity, right? You pray to, thank the math God, whatever. Yes?
The math. Is it related to stage and push? Stage and push? Like,
Only because their identities have squares in them. Yes, but we use that later, that fact later on. Okay, so what are the critical numbers then? What does this give you anything?
No.
No, because exponentials can't equal 0. They have an asymptote there, unless they've been moved up and down, and this one hasn't. So that doesn't give me anything, but what do these two give me?
2
No.
1 over 2.
1/2 and negative 1/2. Yeah. You gotta be careful. Don't let your brain say, I got this. Say, no, brain, no. Alright. How are we doing so far? I mean, this is going to kind of rule our lives for a while now in this class, is finding critical numbers. And guess what we're going to do? We're going to take second derivatives and find critical numbers for second derivatives. And they're going to mean something. Like we already figured out earlier, if you were paying attention. We'll do it again, don't worry. And now the sign diagram is nice. It's only got negative 1/2 and 1/2 on it. They're both multiplicity 1. 0, I can figure out what it is at 0. At 0, it's what? It's positive times negative times positive.
Negative.
So it's negative in there. And then it's going to change sign on both sides. How are we doing? Cool. So it looks like it's increasing, then it's flat, then it's decreasing, then it's flat, and then it's increasing again. I overstated the flatness there, but who cares? This is definitely going to be a max, and this is going to be a min. So where's the max at? It's going to be negative 1/2 comma something. That's where your calculator comes in handy. Because I can't plug a negative 1/2 in easily. And I'm okay with that. Yes.
Shouldn't the 0 be positive? Isn't it 1 minus 0?
Oh, what did I do? I got this backwards. Shit. So when you plug a 0 in, I like to think it's positive, positive. There you go. So I'll reverse that. So this will be down, flat, up, flat, down. There you go. Thank you. So the minimum would be there. Something was bugging me there. Be quiet. So, I mean, obviously, I keep reminding you, by what I do and what I say, I am human. If you notice a mistake, let me know. Don't feel like you're wrong. I'll make stupid mistakes like that all the time. So, negative 1/2, comma, whatever the hell happens. Somebody got that yet? I don't know what it's going to be.
Yeah, it's like a decimal. It says negative,
Sure.
negative 0.30326.
All right, we'll say 30. Good. Because that's all I can fit. And then max, you might believe, because there's some symmetry here, that it's going to be positive 0.30. Yes. Isn't it crazy? Because the original function has a lot of good symmetry in there. Believe it or not. I like it. So that's not too bad, right? That idea itself. So, I mean, that whole process we just did will carry over into second derivatives. We just have to know what they mean when I find critical numbers and I do a test on them. What does it mean? Well, who can tell me? What does it mean? When the second derivative is 0, who remembers what that means? What's happening there? So, what would it look like if the second derivative was positive? Who can tell me?
The slope is becoming more positive.
Yeah, slope is increasing. So it's going to look like what? What's a quick phrase you can say? It's going to look... So if f double prime is positive, it's going to be cup up.
Up, yeah.
Right? And then if f double prime is negative,
It's down.
it becomes cup down. But somewhere in the middle is where the second derivative is 0. So this is a very weird little position. This is what we call, some of you guys already know the word because I've heard you say it, it's called an inflection point. So you guys might realize this is related to a bonus question I asked, I can't remember what test, where I said, where is the slope the most negative or something like that. In this case, it would be the slope is most positive for this function I've drawn where the second derivative is 0. Because after that, it's going to be decreasing now, so now it's going to get less slope. So it's getting more and more and more slope, and then less and less and less slope. So of course, right there in the middle is the most positive slope. And the same thing's going to happen if I do this. There's an inflection point there. With calculus, I can find exactly where it is. Okay, so let's do this. One last thing here today. I want to show you the second derivative test. Oh, let's see. Yeah, that's done. Yeah, sure. We'll just do this one again. I like this little function. It's a nice little function. So the first derivative we already did earlier. Alright, we already found the critical number there was 0. What's the second derivative of this thing going to be? What do I have to use?
Product rule.
Good. So this guy's derivative is -2. Now here's the funky thing. This guy's derivative is this. Each exponential stuff, whenever there's an e to a power in your function, that kind of thing's going to happen all the time because it repeats itself. Right? The derivative has it in it again. I already did this guy's derivative. It's this. So just put that whole thing right there. I don't know if you guys see what I just did. And if you don't, you just do it like always. It's a beautiful little shortcut. You already did the work. So then I get, let's see, if I factor this thing, you can take a -2 e negative x squared out. And I'm left with 1 plus, I'm sorry, this will be minus here. There's too many 2's here. Let's see, this will be x squared. 1 minus x squared, I think. There's an extra 2.
Yeah, 2.
Thank you. So then, what's f double prime of 0? Now here's, so instead of doing the whole number line, I really want this to make sense. At 0, if it's negative concavity, it's going to be, I'm sorry, I just said that word, I haven't used that word yet. If it's concave down, there it is again. If it's cup down, it's going to be a maximum there. If it's cup up, it's going to be a minimum. It's almost too beautiful to believe. And what controls which one it is the second derivative. That's what the second derivative tells you, is the curvature of the graph. So the first derivative tells you, is it going up or down? Well, that's nice for a derivative. That's very nice. Second derivative tells you how it's going up or down. It could go up like this, or it could go up like this. Unemployment, this one, I'd rather have it be this if it's going to be anything. If it's going to be increasing, I'd rather have it like less and less. I don't want unemployment to be like this. Oh, shit. Shit. Right? And you hear this all the time in the news about the economy. The rate of decrease in jobs is increasing, whatever. You hear them say it all the time. They don't even know they're talking calculus, which I love that fact. There's calculus coming out of the mouths. They're like, no, never. So what do you get when you plug a 0 in? This is going to be negative 2 times 1, right? So it's negative times positive. This is 1, right? Negative 2 times this is positive. Who cares? So it comes out negative. So it's less than 0. So it's cup down. So this is going to be a max. I like it. And look back at what we did. It wasn't a max that we discovered on this problem? Was the max at 0, 1, if I remember correctly, on this the same function we did earlier? Or don't look back if you don't want to. Sorry. Take my word for it. So this is the second derivative test. This is in place of doing this. Blah, 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 figuring that out. They both tell you the same thing. The evil thing about this is, tell me what the results of this. Well, we just figured out if the second derivative at a point is at a critical number. Let me call it C for critical number. If that is, do I want to spell correctly? Sure. Critical. If that is less than 0, then it's going to be a max, right? So cool. Up, down. If that's greater than 0, it's going to be a min, because it's cup up. What if it equals 0?
So it's a point of inflection.
No. I don't know. Inconclusive. That's inconclusive. You have to go back and do the first derivative test. So the second derivative test is really nice and quick if the derivative is quick, but sometimes it can come out inconclusive. So some of you guys right there are like, well, screw that test. But it's a really nice test to use. It's relatively quick. If the derivatives are nice, I'd much rather do second derivative test. This might come out inconclusive, though. That's the thing you have to go into it realizing. Then you have to go back and do the first derivative test anyway. Okay, that's all I got. I think it's plenty for first day back from break. It's more than you wanted. Anybody not get their stuff back?